Types of beams. So we have actually three type of beam if I write: primary beam, secondary, and then joist or stringers. So we have mainly these three type of beam. The primary beam, which are also termed as girders, so in case of steel we term it as girder. So the primary beams that are frequently used at wide spacing supporting the smaller beams and other structural components are called girders. So these run between the columns, column to column. Their span is between column to column, and they support the secondary beams or some other structural elements. Frequently girders are made up of build-up sections. So mostly in case of steel, these girders are made up of built-up section because they have larger span and they are supporting larger loads. So the hard rolled section are insufficient for that span as well as loading, so we need to go for the built-up section. So these are supported directly on the columns. So the primary beams or girders are directly supported on the column. So from this column up to this column, the beam will be termed as girder or primary beam. So then secondary beams, these are relatively smaller beams resting on the primary beams or girders, carrying load of lesser part of the root and having smaller span. So if this is our primary beam between the columns, on this side again this is the primary beam, so the beams which are running perpendicular to this will be secondary beams. Okay, next is joists. Joists are closely spaced and frequently having truss type webs. So this is primary beam, these are secondary beams, and beams which are perpendicular to the secondary beams will be joists. So these are joists. So these joists are normally very closely spaced, so they support the very smaller area of the roof and they have very less span, so their span will be from this secondary beam up to the next secondary beam. So here if we see, so this is the primary beam or girder, the beam which is perpendicular to that girder is secondary beam, or in case of bridges we term it as a floor beam, and the beam which is perpendicular to the secondary beam, this is termed as joist. So these are very closely spaced. So the purpose of providing these joists is to minimize the strength requirement of the slab. So with the presence of joists, the strength requirement of the roof sheeting or slab are greatly reduced. So when we provide the joists at closer spacing, the strength requirement, or we can say the thickness requirement of the slab, is significantly reduced because of the lesser span. Here the span of the slab will be only this one. Okay, next is stringer. So these stringer are, we can say, comparable to the joist. So in case of bridges we term them as a stringers. So longitudinal bridge beams spanning between the floor beams, or we can say secondary beams, are placed parallel to the roadway are called stringer. So if in case of bridge structure, so this primary beam will be termed as girder, this secondary beam will be termed as floor beam, and this joist will be termed as stringer. So they will run along the center line of the road. So here we can see, here we have a deck slab. So these are stringers which are running parallel to the roadway, and these stringers are resting on the floor beam, and these floor beam are resting on the girders or trusses, and these girder or trusses are spanning between the embankments or between the columns. The next type is lintel beam. So lintels are members supporting a wall over the window or door opening. So in case of wall, so here we have a door opening. So above the door opening or window opening we provide a smaller beam. So this smaller beam is termed as a lintel, and this supports the load of the wall above this opening. Next is spandrels. So spandrels are actually the edge beams. So in case of buildings, so for example we have column over here like this, so we have many beams. So in case of high-rise building we have walls at the outer periphery, and the load of these walls is significantly high. So the slab alone cannot resist the weight of these walls, or the walls itself cannot resist their load because of the high-rise building. So the bottom story walls will be subjected to significantly high load. So in that case we need to provide a beam at the edges that will support the load of the wall above it. So this beam is termed as spandrel beam. So next is purlins. So these are the beams in case of truss roof system. So these are spanning between the panel points or between the trusses. We normally use that section or angle section or channel section for the purlins. So if we talk about the spans of primary, secondary and tertiary or joist beams, so the main beams are primary beams. In case of hot rolled section, their span should be less than 12 meters, and the span of secondary beams lie between 4 and 6 meters, and the span of steel joist lies between 2 to 4 meters. So if the span of beam is primary beam is more than 12 meters, so we need to go for the built up section, or we need to go for the truss.